Okay, we're going to go over higher order derivatives, velocity, and acceleration. We might get into one example, but really we're just going to talk about the theory of it. Okay? Higher order derivatives. All that is finding a derivative of a derivative. And the higher order can go on and on. We're really just going to focus on second derivatives. So, we know f at x is denoted at f prime x. That means that's its first derivative. If f at x needs a second derivative, we denote it as f double prime x, okay? And that's also the derivative of f at x. We'll get into an example of that hopefully at the end of this. The reason we talk about things like that, strictly for velocity, is for this. An object moves along a straight line with its position determined by a function of time. So position on a straight line is this equation here, or this is the function notation to represent it. Okay, so this is straight line in time. Where on a straight line in time? And it'll be denoted as this. The velocity of that object, they denote as v at t, which is also equal to the derivative of s at t. So that function. We derive that function, that will get us velocity of an object. Acceleration of an object is denoted by a at t. Makes sense. A in terms of time is acceleration in terms of time. Velocity in terms of time is v at t. Our acceleration is equal to the derivative of our velocity or the second derivative of our position along a straight line. Either of those are equal. Okay. So let's say we are trying to find the velocity. We find the derivative of our function. That gives us v at t. And then we derive that function to find the acceleration, or the function for acceleration. When we have those rules, we're going to apply them. These are some quick things to help us out. Velocity. So we have negative velocity. Negative velocity is when v at t is less than 0, or s prime t, the derivative of our function, is less than 0. And all that means is we're going left or down along our straight line. We're either heading in the left direction or down. So less than 0, think of it like a Cartesian plane. We're going in negative directions. We either go to the left, if it's a horizontal line, or we're going down a vertical line. That would be a negative direction. Remember, we're always talking about a straight line, that s at t. Positive velocity is when, obviously, it's greater than 0, or the derivative of the original function is greater than 0. Those are the same thing. And in terms of a Cartesian plane, that's going in a positive direction or upwards, right? Again, straight line. So if it's a horizontal line, we're going to the right. If it's a vertical line, it's going straight up. We're always moving in a straight line. And zero velocity is when it actually equals 0, okay? So we're at a standstill. We're not going up nor going down. You can think of it as a changing point. Sometimes something goes up, and then it stops, it starts coming down again. That changing point is when the velocity will be 0. Okay? Acceleration. Now we know acceleration is the derivative of velocity, or the second derivative of our original function. And that's when velocity is decreasing. When acceleration is negative, our velocity is decreasing. Okay? Think of it like our speed or magnitude is decreasing at this time. If acceleration is positive, obviously that's when a at t is greater than 0, or velocity in second prime are greater than 0. That's when the velocity is increasing. We are thinking of it almost like we're moving forward. It's increasing. And 0 acceleration is when velocity is neither increasing or decreasing. We're constant. Our velocity is maybe 10 meters a second, and we're not speeding up or slowing down. We are traveling at 10 meters a second over and over and over again in time. Speeding up and slowing down are technically, they don't technically have to do with positive or negative acceleration and velocity alone. They're when they're together. So I want you to think of this idea. An object is speeding up when acceleration and velocity have the same sign. So what that means, if velocity is positive, we know it's either going up or going to the right. And if acceleration is positive, it's going the same direction. So this is speeding up. Think of it like double arrows. Okay? We're actually speeding up in terms of speed. If you think of it like vectors, it's like 2 arrows in the same way. Or if they're both negative, it's going downwards or to the left. And acceleration is going downwards or to the left, so it's speeding up in those directions. It's either going down quicker and quicker or going to the left quicker and quicker. The object is slowing down if we have different signs. Let's just say we're on a horizontal line, okay? If we're going in a positive direction with velocity but acceleration is negative, it's slowing us down. Think of it like opposite vectors, okay? And the vice versa could be said for that. That's how we know if something is speeding up or slowing down.